Hello everyone. Today we are going to see what is 1 to the power infinity exactly means. Okay. So what is 1 to the power infinity and why it is one of the indeterminate form? Why it is one of the seven indeterminate form like 0 to the power 0 by 0 or infinity by infinity, 0 to the power infinity, 1 to the power infinity and so on. So how to calculate this? We know what is 1 to the power 1 is equals to 1. Similarly, 1 to the power 2 equals to 1. 1 to the power 3 is equals to 1. And so on, 1 to the power any higher power, say 10 to the power 5, is also equals to 1. So is that does mean that 1 to the power infinity equals to 1? It's a big question. Okay, but this is one of the indeterminate form. We cannot directly evaluate this, but we can use limit for this. Say limit x approaches to infinity, f of x can be one procedure to evaluate this type of numbers. So suppose say f of x is equals to 1 plus 1 by x whole to the power x. Okay, now if you put limit both sides, as x approaches to infinity, f of x is nothing but limit x approaches to infinity 1 plus 1 by x whole to the power x. Now as x approaches to infinity, this will vanish because 1 by infinity is nothing but 0. So subsequently it will become 1 plus 1 by x to the power x, and it will approaches to 1 to the power infinity form. So this function can be used to tackle the numbers of the form 1 to the power infinity. And via calculus technique, we know this number is nothing but e. Okay, exponential e. Limit extends to infinity, 1 plus 1 by x to the power x is nothing but e. Similarly, we can also calculate one more function, limit x approaches to infinity, f of x, where f of x can be written as 1 plus 1 by x squared to the power x. But this answer becomes 1. Okay, and this also forms 1 to the power infinity form. So that is why it is of indeterminate form, because he also will get this limit is of the form 1 to the power infinity, and this also is 1 to the power infinity, but our answer is 1, but in the previous case it is e. So we cannot handle 1 to the power infinity form. That is why we have separate methods to handle via limiting procedure, okay, by taking limits. So if we have this form, limit extends to infinity, f of x to the power g of x. Okay, if we get this is of the form limit extends to infinity, or this as the form 1 to the power infinity, this thing after putting this, then what technique we can use? We can take this g of x as some y and then take logarithm both side, f of x to the power g of x is equals to log y, and then taking this limit outside, this one will become g of x log f of x. Why? Since logarithm of x to the power a is nothing but a logarithm of x. That is only because if we take limit outside, logarithm of f of x to the power g of x is nothing but g of x log f of x by putting this property, and log y as it is. Then what we can do, log y is nothing but limit x tending to infinity g of x whole divided by 1 by log f of x. Okay, and then what we can do finally, because we have to find y, which we have taken this limit x tends to infinity f of x to the power g of x nothing but y, and that only we have to find out. So finally what we can do, y is nothing but, if log y is this quantity, y is nothing but exponential of this quantity, exp of whatever we get this side. Okay, g of x by 1 by log f of x. Okay, a simple example can do. See, for example, if we take, you have to find out limit extending to infinity 1 to the power x. This is of the form 1 to the power infinity, because after putting infinity in x, we will get of the form 1 to the power infinity form, which is one indeterminate form. So what we can do, we can take this whole term as y. Say y is equals to limit x tending to infinity 1 to the power x. Now proceeding in the previous way, which we were told to us, log y is nothing but limit x tending to infinity log 1 to the power x. Okay, and because log can be taken inside log of limit, and which is limit of log, nothing but this. Now this can be simplified further as limit x tending to infinity log 1 to the power x is nothing but x log 1. Okay, because log a to the power b is nothing but a log b by using that property. Okay, once again I can write, since log a to the power b is nothing but b log a. Okay, after using this property, what we can do, limit x tending to infinity x into what is log of 1. Log 1 is nothing but 0. Okay, that you must remember, that was log 1, since log of 1 is nothing but 0 and log of e is nothing but 1. Log 1 is 0. So putting log 1 equals 0, what we will get, limit x tending to infinity 0. Okay, x into 0 is nothing but 0. So if we put limit x into 0 is nothing but 0, from which we get log y equals to 0. Okay, so log y equals to 0, then what is y? So if log y equals to 0, which we got by the previous steps, that means if we take exponential both sides, exp of log y is equals to exp of 0, which is nothing but e to the power 0. And what is e to the power 0? Anything to the power 0 is 1. Now this is e to the power log y is 1, and we know e to the power log a is nothing but a. Okay, we know since e to the power log of anything is that thing. Okay, so what we can do, e to the power log y is nothing but y, and that is equals to 1. Okay, and that only we have to find out. And what is y? Y is limiting value of x tending to infinity 1 to the power x. Okay, what is y? Y is limiting value of x tending to infinity 1 to the power x, and that is equals to 1. and that makes the indeterminate form 1 to the power infinity. So hence, by using the indeterminate formula or indeterminate form, limit x tend to infinity 1 to the power x, which will give rise to 1 to the power infinity, is equals to 1. Okay, thank you.